Hello. In this video, we're going to go ahead and look at continuity again. We're going to use the following graphs to determine if each function is continuous at the indicated x value. So the first thing we're going to look at is f of x at x equals 3. So we have a bunch of different graphs down here. We label each one of these. Here, this is f of x. So notice we want to look at f of x at x equals 3. So here's x equals 3. And notice that there's a hole in the graph. And because there's a hole in the graph, that means f of 3 is undefined. Therefore, that first condition, or condition 1, is not satisfied, which means that this is discontinuous. In other words, it is discontinuous because of condition 1. Now remember, the three conditions that we have is that the function is defined at that value. The second one is that the limit as x goes to that of f of x is defined, or exists, I should say, is probably a better way. And the last one is that the limit as x goes to k of f of x is equal to f of k. So that first one makes this to where the function is undefined, so therefore this is discontinuous. So these three have to be satisfied in order for it to be continuous. Awesome. For the next one, h of x at x equals 0. Well, h of x is here. And notice x equals 0 is right here. And now notice that the function is actually defined right there. So that first condition is good. Now let's look at the second condition. The second condition is, does the limit exist? Notice that as we go to 0 from the left-hand side, it's -1. 0 from the right-hand side, it's +1. Those two are not the same thing. They're not approaching the same value. Therefore, no, that doesn't work. This, therefore, is now discontinuous because the limit is not defined here. Alrighty, now let's look at C, which says g of x at x equals 4. Well, here's g of x. X equals 4 is here. Notice that the function is defined. Good. So that first condition, check. The second condition, well, let's look at the limit. The limit as x approaches 4 from the left is approaching -2, and the limit as x approaches 4 from the right is approaching -2. So the limit exists. Now for the third condition, is the limit, which is -2, equal to the function value of 1? -2 does not equal 1 as far as I can tell. Therefore, no. This tells me that this is in fact a discontinuous, or that this function is discontinuous at x equals 4. Okay, now for the last one. For k of x at x equaling -2. Well, -2 is right here, and oh look, that's a vertical asymptote. Vertical asymptotes mean that the function is undefined there. Therefore, that first condition, no, that doesn't work, which means that this is in fact discontinuous at x equals -2. Now, these are all at particular x values. Because if you look, for all of these, this is just continuous everywhere else except for at 3. This is continuous everywhere except for x equals 0. This is continuous everywhere except for x equals 4. And this is continuous everywhere to the right of -2. So it is continuous everywhere except for at these. So here, All of these are discontinuous. It's just that some of these have different reasons than others. Alrighty. Well, let me go ahead and show the entire thing. There you go. I think I'm going to go ahead and end it here, and I will see you in the next video. Have fun.